Hey everyone, welcome back to the channel. I'm so happy that you're here. Today we're going to be talking about promises. I've taught hundreds of students JavaScript, and one of the most common early hangups is on promises. And I think the reason for that is a lot of people, when they learn them, they focus too much on what promises are, and they're missing a lot of context as to why we need them. In this video, we're going to be diving deep on not just what promises are, we're also going to be talking about why we need them, what problems they solve. We're also going to be cracking the hood and looking at what a promise implementation looks like in JavaScript. And then finally, we're going to be offering some criticism. See, when you really understand something, you should be able to see its shortcomings as well, and promises certainly have them. So at the end, I'm going to provide some criticisms of promises that should look really impressive to employers in an interview environment. Before we get into it and start talking about promises, I want to just talk about two quick things. The first is I'm sorry for the state of my apartment in the background. I've got buddies in town this weekend, and it's hard to keep everything nice and organized when you've got friends from out of town visiting. The second thing I wanted to talk about is that this video took a lot of effort and preparation. So I would really appreciate it if after you watch it, if you enjoyed it and you found it helpful, please leave a like, leave a comment with any questions that you have, and consider subscribing. That's how I can grow this channel and keep making content like this to hopefully help you on your programming journey. Also, down in the description below, there should be timestamps for each topic. So if you already know something, feel free to jump ahead to the parts of the video that you find most useful for yourself. So I think it's really important whenever you're learning a new topic to learn it with a practical example so that we can constantly apply what we're learning to something that's kind of tied into the real world. And we can see how our implementation changes as we learn these new concepts. So here's our example. You're working for a company and you've been approached by your project manager to build a component that allows users to see the different payment options that they have on file. So a user might have some cards, but we also want to give them the ability to show bank information. And the question is, how would you build something like this in JavaScript? So here's a look at the systems that we have in play. So in order to build a component like this, we're going to need information from multiple places. And the reason is most companies, when they're storing credit card or any payment information, they don't do it themselves. They offload it to another company for a wide variety of reasons. But one of the big ones is that holding on to true card information or bank information is a large liability. So all we have in our own database is the user's information themselves, what users logged in. So in order to get the information to populate this component, we're going to need to grab stuff from a few separate places. Our card information in this example is in Stripe, which is just a payment processing system. And our bank information is in Plaid. And these two have an integration. So Stripe and Plaid have already set up some stuff for us so that they can communicate. And then our user information is in our own database. So in order to get stuff, we're going to need to go and grab the user information from our database. Then once we get the information about the user that's logged in, we're going to need to go and get their current cards on file or the payment methods on file from Stripe. Stripe's going to give us that back. And then the way that Stripe works is that some of those payment information or payment methods, may be flagged as bank accounts. And when that's the case, we need to go to Plaid and we need to get information about the user's bank account. Once we have all the information from these separate services, and critically, they need to be ordered. We need to get stuff from this one first, this one second, and this one third. Excuse my handwriting, it's not the best with a mouse. But once we have information from these separate services, then we can finally render our component here. The question is, how can we even get information from those three services? Because JavaScript has a limitation for us that makes it a little bit difficult. JavaScript is single-threaded. So if you've written any JS, you've already ran into the fact that JavaScript is single-threaded. And we can see that by looking at a pretty basic example here. So we know that JavaScript, and essentially runs from top to bottom. There's a little bit of caveats there with hoisting, but for all intents and purposes, things run from top to bottom in the order that you write them. So with this console log string that we have here in the center, in console we're going to see 1 and then 2 and then 3. JavaScript is doing one thing at a time. There's no real way for us to say, here print this 1 and then print this 3 and then print this 2 without breaking out of that single thread. The problem is that presents some limitations for us when we're going and grabbing information from those services that we talked about in the last slide. The reason is to get that information is going to take some time, and I'll show you what I mean. So back at this example here, let's just think about grabbing the user information for the second. So when we go and grab user info, that process of getting user information from our own database is going to take some time. It's not going to be something that's instant, right? We need to go to our backend service. The backend service needs to look up the user that's logged in. They need to stringify, convert that record into JSON, and then send it back to us. That's not something that's going to happen instantly. And that presents a problem. The reason that that's a problem is, and excuse me, EpicPen is being a little bit of a pain. Here we go. The reason that that's a problem is that since JavaScript can only do one thing at a time, if we tell it to go fetch that information and we use the single main JavaScript thread for that, we're going to run into some big issues. So I'll show you what I mean. A way we could mimic doing that synchronously, and when I say synchronously, I mean just doing that action of getting the information from our backend on the main JavaScript thread. A way we could mimic that is with a while loop, right? So imagine that while this is running, we're going to our backend and we're fetching information, and then once it's done, it comes back. Now the problem with that is that since JS is single-threaded, nothing else can happen while that while loop is going on. And I truly mean nothing else. So if we have some web app, if a user's trying to click a button, but we're synchronously fetching information from the backend, the button will just do nothing. And I'll show you exactly what I mean. 1 second, because I have to swap to a new tab. So I'm on my YouTube channel here, and I want to prove to you that JavaScript is single-threaded. So here's how I'll do it. I'll come and I'll write a while loop. I'll say while true. And while that's true, I'm going to just console.log, fetching info, just like we had in that last code example. Now, what's going to happen is when I'm running this while loop, the site itself just won't work anymore. And the reason is the main JavaScript thread is busy doing this while loop. So it won't be able to handle button presses. It won't be able to run any animations. I'll show you what I mean. So I'm going to go ahead and run this, and it's running. And if I come here, notice like the hover effects aren't even working. I can't click anything. None of these links are going to work. And eventually this tab will entirely die. Now, I know this example is not quite the same as fetching information. It runs forever. I know that. But even if taking just a second to go to the backend and fetch some information, even if that only takes a second, that's still a full second where users will be clicking buttons that just don't do anything. That's a terrible experience. And what happens if the backend's down and it takes 30 seconds for the request to fail? Then we're going to have 30 seconds where the site is just completely unresponsive. So this async the synchronous, fetching is not an option. We can't do that. Fortunately, JavaScript has a solution for us, and it's over here. It's the event loop and the DOM APIs. Now, I'm not going to get into too deep talking about the event loop itself. There's a lot of great videos that are talking about how the event loops. But essentially, the browser, Chrome in this case, is written in a lower language, C++, a language that has access to these other threads. And what JS has for us is that there's these additional APIs that we can call that will run processes asynchronously on separate threads. And then when they're done, they're going to give us that data through a function that's queued up via the event loop. Again, if you want to learn more about the event loop, I'll link some great resources and videos in the description down below for you to learn more. But what we need to know is that when we want to do something asynchronous, what we're going to do is we're going to call a function such as fetch in the Chrome example. We're going to call a function like fetch that's going to execute an AJAX call in the DOM API. That's going to run that call on a separate thread, and when the call's finished, it's going to queue up some function for us with the data that when the call stack is clear, so when JavaScript's not doing anything, right, the page is rendered, we're done doing this stuff on the main thread, when JavaScript has time, it's going to queue up that function, back into the call stack, and it's going to run our logic. That's the way that we handle asynchronous operations in JS. The way that this has been done historically is through callbacks. So we would queue up a AJAX call to happen asynchronously. That AJAX call would happen, and when we make the call, we would provide the DOM API with a function, and we would say, hey, when you're done, when you get information back, go and run this function after. That's our callback. So we would have, some AJAX call again. We would call it, and then we would give that AJAX call some function. Maybe that function is this, mouse move or whatever. And then once that AJAX call is done, the AJAX call itself would put it in the event loop for us, which when the call stack is clear would then get ran. And then we can do stuff with our data. That's great. That's great. Hopefully you understand it from a high level, but let's look at an implementation. So here's our implementation, or an example one. And I want to note that this get function here is just contrived, right? And the reason it's contrived is I want to show you how it changes over time. I'm not using like an actual fetch API or something. It's just an example. So again, to think back to our example, just so that we review, we need to get information from our own database, and then we need to get information from Stripe, and then we need to get information from Plaid if there's any bank payment methods in Stripe. So here's some code that you might write to do that. And this is using the age-old method of callbacks. So what we have here is we're doing this GET request to get some information from our own API. We see up here that we're getting data about our user from our own API. So we send this GET request off for, user number 1. We get the user data back. Once we have the user data, then we can grab the information from Stripe here, and we go ahead and we append the user's Stripe ID here so that Stripe knows who we're getting information from. Then we have the Stripe information back. So here's the Stripe data. Once we have the Stripe data, we can go through the payment methods and we can see, hey, is there any bank payment methods here? If there is a bank payment method, we know we need to go to Plaid. So if there's a bank payment method, we're going to go ahead and we're going to send another API request here. We're going to send that API request to Plaid's API, their Stripe integration, and we're going to append that bank payments Plaid ID. Then Plaid is going to give us back the bank data, and what that bank data is going to contain is it's going to tell us if their bank account has been confirmed, which means we can charge it or not. And then finally, when we're done with all of that, we've confirmed the user's payment methods are valid, and we can go ahead and we can show the user their payment options. We can render that component. If the bank account's not confirmed, maybe we want to show them some error. Excuse me, I can't talk sometimes in these long videos. We want to show them some error if it's not confirmed. And if they don't have any bank payment information, so in the case where they only have cards on file, then we can just show them that information straight away. We don't need to go to Plaid and confirm it. So here's our flow, and hopefully you understand what we're trying to do here. This flow has some issues, though. And can you spot them? Think about what might be some problems with the code that we've written. Just think about it for a second. Well, the code has a few issues. The biggest one is that we're running into this nesting. And it's not that big of a deal because we're only going about 1, 2, 3, 4 blocks deep. But as you might imagine, this flow is just our base flow. And over time, we might add more additional things to it, right? What happens if, we're supporting bank payment, all of a sudden we want to do maybe an integration with Venmo, some PayPal payments. This is going to get very complicated, and we're going to have to do a lot of this nesting. Because each of these things is reliant on the other one finishing, we have to nest them inside of each other. This nesting, this super deep level of nesting, is what we would call callback hell, and it's something that you're going to learn a lot, and it's something that a lot of people say promises solve, right? Promises are a solution to callback hell. If you go look up interview questions about promises, one of the most common ones is, what are promises and what problem do they solve? And the common answer is, promises solve callback hell. And when I was teaching, I would ask students that question, and they would say that answer, promises solve callback hell. But they don't know what callback hell is. This is what callback hell is. It's that you're so deeply nested here that it can be extremely confusing to know, one, where you're pulling information for, right? If you're pulling stuff from this Stripe data, you have to look pretty far up, and especially as this gets more complicated, it'll get even worse. You have to look up into like additional functions that can sometimes be way above to find out where that information comes from. The second thing is that it can be confusing to read, right? It's hard to tell when we are executing these async functions, right? It's not very explicit. It's like, okay, we're getting this thing, we're getting this thing, we're getting this thing, but there's nothing that's clearly telling us, right? At first look, there's nothing that's screaming out to us and it's saying, hey, these are the areas where we're doing these async operations. And that's something that can be scary. You want to write code to be as readable as possible. When you're writing code professionally, or even just for yourself, you're not writing code for the computer. You're writing code for other engineers, and those other engineers might just be future you. So whenever you have something like this, like callback hell, where we're making our code kind of needlessly complex, that can be a huge problem at scale as the code base gets bigger. Because I'll tell you, I've ran into some really large asynchronous functions that are doing a lot of callbacks, and it can take me 30, 45 minutes to really wrap my head around what's going on. Whereas if they were using something more elegant, such as promises, it would be a lot easier to read and go through, and it would significantly decrease the amount of time that it would take for me to get ramped up and dive in. So that's the problem that promises are here to solve. They're here to solve this callback hell issue. They're here to give us a more elegant way to handle asynchronous operations than just simply, hey, go get some data and here's some function to run when you're done. So let's dive into an example, and it's the same one, but this time we're using promises. So if you can see here, we're doing the same kind of thing. We're getting the information from our fake API about our user. Then we're going and getting information from Stripe. Then we look at the payment methods, and if there's a bank, we go and we get the bank information from Plaid. And then finally, we show the payment options if the bank was valid. Otherwise, we show some bank error. And if they don't have a bank on file, we just show them the cards from Stripe. And there's a few things to learn here. The first one is we can see the syntax differences between a typical callback and a promise. So here, instead of calling our get, I've made up this fake get promise function, and we just pass it the URL that we want. Notice there's no additional comma here like there was on the last example, and we're not passing an additional function. We're just calling this standalone with this URL that we want it to go get information for. This tells us something about promises. What it tells us is that this function here is returning a promise, right? So the entire function here, it outputs a promise. It's the result of that function. Then, since it's outputting a promise, we can attach a handler for that promise. Now, promises have a wide variety of methods, and we're going to be looking at different ones throughout the video. But the most important one that you grasp is this .then handler. So the get promise goes, and it says, okay, hey, we're going to grab information from this API. And once you're done, we're going to call any .then handlers you have chained to this promise. So we only have one. We have this .then chained. And then here, this is that data coming back, right? But functionally, it's acting very similar to our callback example. We're going to go and grab this information. Then when it's done, here's a function, callback essentially, to run when that occurs. Now you might be noticing something here. We were talking about callback hell on the last slide. Have we fixed that? Ask yourself that question. And the answer is no, we haven't. You might notice here, we have this user data coming in. And then within the same function scope, we're calling another get promise, and then we're calling another one here. Right? We have the same amount of blocks as we had in the other example. You see, promises on their own don't fix callback hell. And a lot of newer engineers, they just recreate the same problems that we had with callbacks using promises. Promises do, though, what they do is that they give us additional tools that allow us to manage something like this. Before we look at a better implementation using promises, I want to take a moment and look at what composing a promise looks like. So here's an example promise. We're going to make our own. So we go ahead here and we define this constant example, and we set it equal to a new promise. When you create a promise, you have the option to resolve or reject. A reject is when something goes wrong. So in our last example, say you fetch information from the API, and the API comes back and it gives you, an error. Then you would reject if you were writing your own get promise. Otherwise, you would resolve. In this example, we're just going to resolve hello. And then what we have here is we're taking our example and we're doing .then, when this resolves is all .then means. So when this resolves, whenever you see .then, think of, okay, this resolve function here is just going to call .then for all intents and purposes. So when you resolve, give us that value. That value is going to be this hello. So hello is going to be the value here. We console log the value, and we should see hello in the console if we were to run this code. There's a few things that are important to learn here that we talked about a little bit, but I want to reiterate them here. A promise is not a function. A promise is a data type, and that's why here you'll notice we're not executing example, right? And that can be something that's a little bit confusing. If we go back and we look at our get promise here, a lot of students, when they see this, they'll think, hey, this is the promise, right? This is the promise here. This function is the promise. That's not true. This function is a normal JavaScript function, and the only caveat, the thing that you need to know, is this function returns a promise. So the function itself is not a promise. The output from the function is the promise. And that's why we're chaining this .then onto the end, right? Because this whole function here, it's outputting a promise. And that's also why, if we go back to this example, we don't need to execute this, right? Because this isn't a function that outputs a promise now. It's just a promise, right? So example is just being directly assigned to a promise. So because of that, we can just chain our .then handler directly onto the end. So let's go ahead and let's dive into this example a little bit deeper. So I have the same example from the last slide here, but this time I've gone ahead and included a simple implementation of a promise in JavaScript. I want to note that this promise is not exactly how they're working under the hood. They're a bit more complex, and I'll give you the caveats that you need to know with this example later. It's mostly here as a learning resource for you because it'll help you wrap your brain around a few complex topics. So let's look at our promise class. So we've got our class promise. We've got our constructor here. This runs this corresponding function that we're getting here, right? So when we call this new promise, we give it a function. That function is this execution function, right? Then the promise class runs our execution function. It runs it with this.resolve and this.reject, which are just, the resolve function, and you might imagine that the reject is down below. I didn't actually write the reject implementation because it's not that important for this example. So it runs it with the resolve, and then, that becomes this parameter here. We call resolve with hello. Resolve here gets called with this value hello. Now, before we talk about the resolve implementation, I want to talk about .then. So when we get this promise back, we chain this .then handler to it, right? This .then has this function that it's taking in. So let's go and let's look over at our implementation for .then. And hopefully it's somewhat similar to what you imagine. We have this then that takes in a callback. And then when that callback comes in, we add it to this resolve chain array. Now that's critical here. The resolve chain is not a single thing, right? It's not just this one callback. It is an array that you might imagine could contain multiple callbacks. It could contain multiple things that you're doing when a promise resolves. And that key point, that is the power that gets us away from callback hell. And then notice we're also returning this here. Okay, so let's look at the next example real quick. Okay, so this next example allows us to really show that resolver chain in action. So we've got our dot then, same as before. We're console logging the value, right? Then notice here, we've attached an additional dot then. So this dot then has this return this, okay? And remember the this keyword, hopefully you've done some JavaScript classes and you know what the this keyword is. But all this is saying is it's returning this same promise instance that we created up here on the first line, okay? So the dot then here, this runs, and then it returns the same example instance here that allows us to chain another dot then onto it. So we have two functions now in the resolver chain. And let's look at how those execute. So what happens is when we resolve something, so this resolve gets called. What the resolve does is it takes that value in our case, this string hello, and it goes through the resolver chain. Okay, so it goes through this array here. And for each callback in that resolver chain, as you might imagine, it's going to run it with this value here, right? We're seeing that it's running it with the value. And that works fine and dandy for this first one, right? So we run it with that value. That value is going to be hello. This becomes hello. We console log the value and we see hello. But there's something really interesting here. And here's where the power comes in. When we run that callback, we're assigning the next value, so the next value that runs, equal to the result of that callback. So we run this dot then function, and then notice here, I'm returning the value plus world. And I'll clear the marker so we can focus on this. So I'm returning that value plus world. What that is going to do is, since this callback function, the first one in our chain, is going to output the value plus world, and remember value is hello, we're going to reassign the value here. This value is going to get assigned to hello world. So then when we go to the next callback in the chain, which is this one here, right? When we go to that next callback, value is now not going to just be hello, it's going to be hello world because we changed it in this callback here. So we change it. It comes out, and the value is now hello world, and we'll see that the console log here ends up hello world. That chaining, that ability to chain these handlers one after another is how promises solve callback hell. And I want to know something. Here's where we need to talk about the caveats with my implementation here. This is a simplified implementation, and there's a few things that it's doing that are a little bit different than the actual promise implementation, and it's important now that we talk about it. The main thing is that when you're doing dot then, it's not actually returning the same example. Instead, what it's returning is it's returning one of two things. It's either returning a brand new promise, or it's returning a promise that's been returned from the callback. Here's what I mean. If you have a dot then handler, like we do here, and that dot then handler is returning a value, which it is in this case, we're returning the value plus world, then what dot then is going to do is it's going to return a brand new promise, and that brand new promise, just like this one we have up here, it's going to be the same kind of thing. That brand new promise is going to resolve immediately with whatever we returned from our callback, okay? Functionally, that's going to behave almost identical to the implementation we have here. Here's the big difference though. Although it behaves the same when we're returning this, primitive value of just a string here, if we were to return another promise, the dot then handler here, it's not going to return a new promise and then nest the promise that we returned inside of it. Instead, it's just going to return the promise. So for example, say instead of returning value plus world here, we returned one of those get requests that we looked at in our prior examples. Well, instead of wrapping that in a whole new promise, it's just going to output the promise handler that we returned from this callback. And I'll show you what I mean. It's, you might get that conceptually, but let's look at an exact example so that you can really wrap your brain around that. So here is that same implementation that we looked at before, this one that we were using .then for, and we were kind of recreating callback hell. Let's look at it using what we've learned about promises. So what you'll notice here is that now, instead of nesting everything inside of this first call, instead what I do is I just have the call return another promise. And remember the behavior of promises. If you return a raw primitive value, so just a raw value, it's going to wrap that value in a promise that immediately resolves. If you instead return another promise, then the callback is just going to output that promise. So what we're doing here is, and this is where it's different than our hello world example. So if we come back to this slide, this is where it's different than this return value world, because this is just a raw value. It's not another promise. Now here, we're returning a new promise. So we go ahead and we run our get request for that API, and then the .then handler is going to return another promise, a new promise. Then here's the power. Since this .then returns this new promise, we can chain another .then onto the end of it. And this .then is not going to apply to this promise. Instead, it's going to apply to this one that we're returning here. You see the power of that? It lets us get out of that really deeply nesting that we were doing in our callback hell example. Now we just get our user data and we use that user data for exactly what we need. And then we're done with the user data. We don't need it anymore. So we return that promise, right? We got the user data. Then we go and we get the Stripe data. And now this here allows us to handle that in a completely separate function scope. So we handle this in this separate function scope. And let's break down the rest of what's going on here. So we return the Stripe API. All right, so this here calls our user data. We get that user data back. Then we return a whole new promise. This whole new promise goes and it gets the data from Stripe. And then that Stripe data comes back here. Okay, well, let's draw that line just a shred better. So we go to Stripe. Stripe data comes back and it goes, there. All right. So we get that Stripe data in. Then, just like in the other examples, we look to see if the user has any bank payment information. And if they do, we do something interesting here. So remember, promises, calling back, when we chain a .then handler onto a promise, it's going to do one of two things. It's either going to return a new promise that resolves with the data that we've given it, or if we return a promise, it's gonna return that promise that we returned from the callback. So if there's the bank payment method here, what we do is we're gonna return it seems like maybe a new promise, but that's not the case. Here's what's important here. We're not returning the result of just this get promise. We're returning the result of the whole chain here. And the reason we're doing that is, remember, this promise here, we still need access to the Stripe data within it when it's being resolved. So that creates a small limitation for us, right? We have to do a little bit of callback hell here, just one layer deep. So what we do is we return, and then we go ahead and we call this new promise. This new promise is going to go to Played. It's going to get the bank account information. It's going to bring it back. And then when we have that bank data, we can check if the bank account's confirmed. And if it is, then we return the Stripe payment methods. Otherwise, we return undefined. Okay? And then since here now, we're not returning the promise, right? This promise resolves. We get the bank data. And then what this is going to do, the .then here, remember the rule, the .then here, since it's returning just a normal data type, not a promise, the .then here is going to wrap this payment methods in a promise, and that's going to be the output. So here, this return is going to resolve with a promise, or the output of it, I should say, is going to be a promise that contains this payment method. And if they don't have bank payment information, we're going to return just straight up the payment methods, which is going to do the same thing, right? This is going to do the exact same thing. It's just going to return a promise that is going to resolve immediately with the payment methods, right? Either way, the output is going to be the same. And then look at how we handle it here. What we do is, since we're getting that those payment methods here in this .then handler, we know that this payment methods, they're either going to be the methods we want to display, or in the case where the bank data is not confirmed, we're going to get undefined. So we can check, hey, if the payment methods are there, then we can show them to the user, right? Otherwise, we can show that bank error, because we know that the only time where payment methods aren't there is, when this bank data is not confirmed, which means we'll be returning a promise that resolves with undefined. So once we hit there, what we do is we go ahead and, we render the user payment options and they see our UI. Do you see how much better this is? It's an easier flow to follow through, but it's not quite perfect yet. There's a few things we still have yet to do. So I'll pose you a few questions. The first one is, what happens when one of these promises fails? Right? What happens if the Stripe API is just down? Now, that doesn't happen very often, but let's say it is, for example. The Stripe API is down. How do we handle those errors? Then the other question is, here, we're doing this additional level of nesting. Is there maybe a better way to do that? Let's talk about error handling. And before we do it, I want to look at our old callback example that we started the video with. How would we handle errors with this old callback example? Well, let's look. So here. Okay. So here's what error handling would look like in a traditional callback. So just as before, we're doing our GET request, but then oftentimes what will happen is we'll have like this user data come in, and then we'll also have an error. Now this error is optional, right? It's either going to be there or it's not. And if there is an error, then, we would expect the user data to not exist and vice versa. So the first thing we would have to do is we have to check, hey, is there an error? And if there is an error, then maybe we call some function to handle it. But then look here. We do our next callback, and we have to do the same thing. We have to check in every single one if there's an error. And I only wrote it out 2 levels deep here. Remember, there was the bank account information as well. So we have like these multiple separate, we handle errors in 3 separate different places. That's not very elegant. Let's look at how promises solve that in a much more elegant way. So here's our promise example again. And notice we've just added one additional thing. So when we have a promise chain with all of these .thens, we can attach a single catch. And this catch is going to catch an error that happens throughout the whole thing. So if this fails, the catch gets ran. If this fails, the catch gets ran. If this fails, the catch gets ran. If I have a syntax error right here and I accidentally put, instead of pm.type, pm.tpe, then guess what? The catch gets ran. It's a catch-all for any issue that goes wrong in our promise. And that allows us to write our error handling in a much more elegant way. Notice here, we only have to catch for the error a single time. We don't have to do it in every single one of these handlers. That's so much more elegant and so much more dry, right? We're not repeating our error handling logic all over the place. So that answers our question about how promises handle errors. Remember, we had another one. The other question we asked about this example is that this here is a little unsatisfying, right? We're not doing the complete dream. We still have an additional function nested inside of another function, right? We have a little bit of callback hell, and it would be a little bit more satisfying if we could get rid of this. And I think there's another issue with this too. Although this is better and it reads a little bit better and it's a bit clearer top down, we're still missing something. It's still a bit unsatisfying, and if you were coming into this code base, it may be challenging to read. So how can we make this easier to read? Well, here comes Async.08. So JavaScript has promises baked into the language, and because of that, they've given us these additional keywords that allow us to interact with promises. They gave us async and await. Now, async await are just syntactic sugar, and all that means is under the hood, these are doing the same .then and promise resolution that we were looking at in other examples. But syntactic sugar is amazing. It can make our code much more readable, and you can probably tell already just looking at this how much easier it is to process. So check it out. we're doing the same thing, but now we're using async await. We've reduced our code in terms of length a lot, and we've reduced it so it's only one single function scope. Our dream is a reality. So at the top here, we had to wrap it in a function, because in order to do async await, the entirety of the code needs to be wrapped in a function, and you need to explicitly specify using this async keyword that the function is going to be utilizing async await. So we have this async function here. Then we call our promise. But notice now, instead of chaining a dot then at the end here, instead of doing, dot then, what we do is we preface it with an await. Now, what's going to happen here? Well, here's what's going to happen. This await is syntactic sugar for a dot then. All that means is what's going to happen is we're going to hit this await, and JS for us is going to wrap the rest of this code up in a nice little callback under the hood for us. And it's going to wait to run the rest of this code until this promise resolves. But it just does it for us. And the value of it doing it for us is that it makes the code extremely readable. So you can think of each of these awaits as like a stopping point. All right. So every time you see an await, the code will stop there for that promise to resolve. And critically, it's not going to stop synchronously. You're not going to block the thread like we looked at in a past example with that big while loop. What we're going to do is it will, stop here. And then, like I said, it'll wrap the rest of this up in a new function for us. It'll go get the promise. It'll resolve with that data, and then it'll run the next thing for us, asynchronously utilizing the event loop. That's really powerful. Look at how readable our codes become. We're doing the same thing, right? We go and we get the user data from the API on this first line. Then, now that we have the user data, we can go and we can get that information from Stripe. Then we can look through the payment methods, see if there's a bank one. If there's a bank payment, we can get the bank data. If that bank data is confirmed, we'll show them the payment options, including the bank. If the bank's not confirmed, then we'll show them their bank error. And then, if they didn't have a bank payment method in the first place, so if they had no bank payment, then we're just going to show them those cards that they had on file. Look at how elegant this is. If I was coming into a code base and I saw code like this, I could read it and get the gist of what's happening in just like a minute. That's so powerful. Whereas that first example would take me 5-10 minutes. I might have to console log some things to figure out where all of that data is moving. We can read this extremely quickly and see what's going on. Now, the way that you typically handle errors using async await is by wrapping it in a try-catch block. So just the same as we had the dot catch handler, we can leverage a try-catch block with async await to get that same benefit. So we're going to do all of these things, but if one of them fails, we're going to catch it with this catch-all handler, and that error is going to come here as E, and then we can have some function to handle the error elegantly. Okay, so a quick footnote about another tool that promises give us. So in the last few examples, we've been looking at a example where we need to have this like cascading functionality. So we've got our info in like a database that we need to then go to Stripe to get, that we then need to go to Plaid, right? It's this kind of cascading thing. There's an order that's necessary. But sometimes you don't care about the order in which things resolve. Say, for example, you were building a page that wanted to show maybe to an administrator 2 separate user information so that they could compare them, for example. Well, with promises, we have access to something called Promise.all. And what this allows us to do is it allows us to create a promise by composing multiple promises together. So Promise.all is a built-in function that's going to take an array of multiple promises. So here we're just passing it 2. We're giving it one promise here and then another promise here. And Promise.all is going to go and it's going to output a new promise, which is an array of wrapping all of them. Or rather, I should say, it's a new promise that's going to resolve with an array from the results of all of them. And that's only going to resolve when all of these have finished. So when every promise that you give to Promise.all resolves, the wrapping promise will resolve with each corresponding value. And we can see that example here. So we do get users, dot then, right? So get users is a single promise. But the data here is where it gets special. When each of these promise resolves, the Promise.all is going to give us that data back from those promise resolutions in an array where the data is in the same order that we have the promises here. So, for example, here, since our first promise that we're giving to Promise.all is one with the user for the ID of 1, when we look in our resolution after the dot then, when we look at the first item in the data array, we're going to notice that it's user 1. And then when we look at the second one, for the same reason we're asking for user 2, it's going to be user 2. Promise.all also works with async await, right? And there's no magic here. The reason it works is because Promise.all is returning a promise itself. So we can do the same async await functionality. So we do that here. Look at this example. We have data and we can remove like this get users middle point. We just go straight up. Here's the data. Await for this Promise.all to resolve. We get these two promises. And then just the same as above, right? We console log the data and it follows the same rules. The first one in the array is user 1 because our first promise in the Promise.all array is the one that's asking for user 1. So that's the gist of promises. Hopefully you understand how they're working and why we need them in the first place. But now that we've dove into that, let's talk about some shortcomings of promises. So what promises are essentially is something called a monad. And what I have here is a little diagram to outline essentially what a monad is. So a monad allows you to take some piece of data, in this case t, and it allows you to wrap it in the monad itself. In our case, it allows us to wrap it in the promise. Think back to that hello example where we were just resolving with hello, right? It allowed us to take the data, hello, and wrap it in a promise. Then a monad also needs a way to unwrap it back out. That unwrapping is the resolving, right? The await or the dot then handler. Now, this type of monad, what you'll hear programmers, especially functional programmers say a lot, is it's an I/O monad. Okay? So an I/O monad, it allows us to handle input-output asynchronously. Okay? And the promise is an implementation of an I/O monad. Now, an I/O monad, typically what you'll see is that I/O monads allow us to compose them together. And we get a little bit of that with something like Promise.all. But what promises are missing that some other I/O monads that I've worked with allow us to do is it doesn't allow us to stall execution to a later date. I'll show you what I mean. Let's look back at our contrived example of what a promise implementation looks like. And remember, although this is not exact, there is one part of this that is pretty damn close. And this is the part. Notice that the second we instantiate a promise, so the second you say new promise, it runs the execution function, right? It goes ahead and it tries to resolve the promise immediately. Now, the downside to that is that we can't compose a promise. We can't create a promise and then wait until later to execute it. The second we say new promise, it runs it immediately. And the reason that's a downside is that when you're building an application, the asynchronous parts of the app are the riskiest parts, right? Those are the parts where we're going and doing something in the outside world, right? And it's really important whenever you're doing something that's risky, you want those risky parts of your application, the parts where you're going and doing something that's inherently unpure, which is going and fetching data and retrieving it, right? Something that might not work. You want that to be on the edges of your application. If you think about the application like this massive tree, you want all of the areas where you're doing asynchronous behaviors to be these leaf nodes. And the downside of promises, where it executes the function immediately, means it can be more challenging to make that dream a reality. Imagine for an instance, if instead of when you're writing promises, the second you do it, it executes. Imagine they added a method that said like Promise.execute. That would allow us to pass promises around like variables without running them yet. So that would allow us to compose these complex promise strings in separate files that are on these leaf nodes, the edges of our application, and then it would allow us to explicitly execute them only when we want to. So a big downside of promises is that they run the second we instantiate them. We don't have the power to say, oh, hey, wait, no, actually, I want to compose this promise string together. Don't run it yet. I'm just creating a recipe to run later on. And other IO monads can give us that. I know it's a bit of a complex topic, but I wanted to talk about it in this video because I think it's important to understand that although promises are great and they give us a lot of power, they're not perfect. There are limitations that they have, and that's one of the big ones. I want to note that although that is a limitation of a promise, it's not completely unworkable, right? We can just wait to instantiate a promise until exactly when we want to do that thing. But the downside to that is that it can pollute and kind of blow the length of our files versus if we had the ability, like I said, to create promise chains in these large separate files, and then we can pass them around to different functions like a variable and then only explicitly execute them when we want, right? That would be awesome, but unfortunately, promises don't give us that functionality. Thank you so much for watching this video. I hope it helps you really understand what promises are under the hood. If you liked it, please consider giving it a like. This video took a ton of effort and time and planning to put together, the most of anything I've created so far. So if you want me to make more content like this in the future, consider leaving a like, leaving a comment, letting me know any feedback that you have. And a lot of the people who watch my content aren't subscribed. It would be awesome if you took a moment and subscribed. It would really help me out. Thank you so much for watching, and I hope you have a wonderful day.